This problem is focused on the understanding of alternating series error. With an alternating series error, you want to remember that first it needs to be an alternating series, which means it must go back and forth between positive, negative, and it does. And I can especially see that it says when n is odd, we've got positive, and when n is even, we have a just flat out negative going on. But to pass the alternating series test and say that it converges because of alternating series test, I have to take the absolute value of the entire formula, and that must do two things. It must decrease to 0. Both of these have to happen. When you read Roman numeral 1, it says that S converges because the terms of S alternate and the limit is approaching 0. That is not enough. That is leaving out this part. It does not converge because of only the fact that it is an alternating series and the limit approaches 0. That's out. The only things left are either it diverges or converges, but let's make sure that we understand why it says what it says. If you look at the terms as you go along, you should take note that the absolute value of these terms is not just decreasing, it's going up and down. It's oscillating. This is not true. And I want to point out that both of these say it is not true that the n plus 1th term in absolute value is less than the nth term in absolute value. Both of them say that. So now it's really just down to, am I dealing with diverge or converge? If you take an infinite series and you rearrange the order of them, if you are dealing with an infinite series that is absolutely convergent, you can rearrange the order and look at it in that rearranged order, and it still converges, then you know that this converges. But it has to be absolute convergence in order for us to be able to change the order. Now, if you look at the formulas going on, one of them is geometric, one of them is p-series, or at least comparable to p-series. So this one right here is 1 over 2 to the power of n minus 1 over 2. Now this is a geometric series. I see that n is only in an exponent, but what is r? In order to find r, I have to remember some exponent rules, and that would be when 2 shows up in the denominator of an exponent, it actually means square root. So that means that this is equal to 1 over the square root of 2 to the power of n minus 1. Once you can see who has the 1 times n exponent, plus or minus isn't going to affect the r, you can see what your r is. R is 1 over root 2. The absolute value of that number is less than 1. Therefore, it converges by the geometric series, and not only does it converge, it is absolutely convergent, because if I take the absolute value of the terms, it will still converge. Absolutely converges. Now let's take a look at the next piece. If I absolute value that formula, and I'm going to make some room for saying that, if I absolute value this formula, I get something that I can compare to a p-series. The p-series that I compare it to is 1 over n squared, and that is a p greater than 1 because my I just wrote what I was, because my p is 2, which is greater than 1, that makes it a converging p-series. And because I can take the absolute value and get converge, it is absolutely convergent. If I take two absolutely convergent infinite series and I change their order by combining them in like a zipper kind of thing, with them being absolutely convergent, it doesn't matter if I change the order of all of the infinite series. The two of them added together create a convergent series. So I get that S converges, although it is not true that it does the decreasing of the absolute values. So remember, it converges, although the alternating series test does not apply.